I'm Naveen. My full name is Naveen Chandugar.
My name is Daniel.
I'm Matthias.
I came from India 2 years ago in Munich. My background includes bachelor degree in electronics and communication engineering.
I coming from Croatia, and I have background in information technology.
I'm originally from Bavaria, so not too far away from Munich. I have a background in neuroscience.
The project belongs to BMW.
Working with acoustics data, so that's pretty nice for me with my background.
Basically, they want to find, they have the sensor data, and in this sensor data they collect very different data points, basically frequencies. They want to find in advance possible failures in the batteries.
They need a classification algorithm to detect anomalies. They in time can identify if there will be a malfunctioning part in the motor and stop it right away.
I think the most important part is the root cause analysis, which we still have to do. It's basically the important part of this project, and the BMW team has explicitly asked us to find out the root cause from the data. Root cause here is basically figuring out which part of the electric engine is the reason behind excessive vibration or noise from the electric engine. This is something we still have to do, which we have not even started yet.
At the beginning of the first phase, we have motor test run. The motor is equipped with some sensor which record vibrations, and then it's manually proved is the motor okay or faulty. So to improve this process, we developed solution which brings artificial intelligence and data analytics, which allows us to automate classification of this test and also automation of anomaly detection, which can help us to identify potential quality issues, and for the root cause analysis for better explaining these potential root causes which anomaly is happening. Now from here I will give to my colleague Matthias so he can explain a little bit more on our approach.
Thank you, Daniel. Also, good evening from my side. So I will guide you now a bit through our workflow. So as we were working with prototypes, there was a lot of inconsistency in the data. So first of all, we had to do some data cleaning and data engineering. And once this was achieved, we set off to implement descriptive and predictive analytics. Before diving deeper into this, I want to take a moment and briefly show and explain to you the data that we were working with. So as Daniel already mentioned, the motor was running at different speeds, and there was a sensor attached to the motor that was collecting the intensity of vibrations at different frequencies. And every frequency serves as a trace back to a specific component in the motor. So how did we use this information to actually assess the quality of a motor? So we had data from new and old motors, and we utilized this information to develop an AI model that is able to predict whether a motor is okay or faulty, but also to really understand the root cause of prediction and to detect potential anomalies. We implemented data analytics and image processing techniques, and we then combined these two methods into a custom dashboard that allows for interacting with the data and to actually visualize and explore the data. So in the end, we were able to deliver a model that is able to predict the motor quality, but also to identify the root cause, as well as detect anomalies and fuse this into a dashboard. So now I'll briefly show you what the dashboard looks like. So there is a drop-down menu from which you can select a data set. The data will then be uploaded, and the model will make a prediction about the motor quality, in this case, okay. And you will see a histogram which helps the technologists to understand actually what is going on. So it helps them to really see the root cause and potentially identify anomalies. And there is also a spectrogram that lets them overview the data and by hovering really inspect individual values. Of course, you can go up again and select another data set as well. So let's do this. Data gets uploaded. And here we see the motor is predicted now to be faulty. You can already see the histogram looks quite different than before. So this really helps in identifying the root cause. And of course, also for this data, there's the spectrogram available, which allows an overview of the data and also inspect the individual values. And this now already brings us to the end of our presentation. Too fast. So to conclude, we are overall able to improve the efficiency and the accuracy of quality assurance by first of all leveraging AI for predicting motor quality, but then also to help to identify the root cause by using data analytics and fuse this into a dashboard that allows for easy interaction with the testing data. So future steps would be, first of all, of course, to integrate this model and dashboard into the test workflow for real-time analysis, and then continue and further evaluate and optimize the model based on new data and feedback from colleagues. And a step a little bit further into the future, leverage a large language model chatbot that enhances the Q&A interaction.
I mean, there are always a ton of things that don't work right, because also this was in the research and development department of BMW. So you're really working with, baby data prototyping, so it's never perfect. Also the data you get is not perfect. So you just have to play around and try a bunch of different techniques, and eventually you see a path unfolding, and then you'll try to continue with this and hopefully end up with the results. We were able to achieve something, so it's very good.
We tried many different approaches and trying different things, so that was very interesting in the whole process.
So for them, of course, they now will need to integrate our solution into their workflow. It's potentially really interesting for them to further improve the model based on new data that they will collect, but also based on feedback that they will get from other colleagues.
Well, the feedback what we got, they are really happy with us, and that we delivered this project in such a short period of the time, and the whole collaboration was so fluent, and it was really, really nice.
We got tons of feedback. I think overall they seem to be pretty happy, so we are happy if they are happy. And it was a really interesting project to work on.
It was a super interesting project, right? Getting to work with BMW, of course, is a great opportunity.
Because you got to work in the R&D department of BMW, but also because I was lacking any business background, so it was really interesting to see how a company this big as BMW is actually working, and how processes are going, and how the different departments interact with each other and collaborate.
A great experience, like cherry on the top of the whole bootcamp. Really amazing time, and very thanks to Constructor Academy for this opportunity. What we got also the BMW group to work on this very interesting and innovative project. So all the best for this experience. It was the best part of the bootcamp for sure.
Also, there was always help from Constructor Academy if we needed any feedback, so thanks to our TA. That was really great, and I'm really happy that it worked out that we are able to get a project like this one with a super famous company that I guess everyone in the world basically knows of.
Yeah.